You know, sometimes the biggest pain point for automating a process isn't your biggest problem. We're going to be talking about some of the things you may or may not want to automate, and I'm going to rant a little bit. So join us. Hello, everybody, and welcome to Industrial Automation It Doesn't Have To. In case you're new to our program, I'm Brandon Ellis, and I'm your host and also the owner of elliTek. Before we start today's episode, I just want to ask that you consider hitting the follow button and the subscribe button, depending upon the platform you're listening upon. Also, if you're listening on Apple Podcasts and you enjoy what you hear, please go to the show page and scroll to the bottom. Leave us a 5-star rating and review. Now that we've got the marketing out of the way, I want to say thanks for tuning in. So let's get started with today's episode. So welcome to Industrial Automation It Doesn't Have To. I'm Brandon Ellis, your host, and with me is Beth Elliott.
Oh, that's a great opening. Thank you, Brandon.
We've got some new sound effects. Brandon Ellis. All right. So hello, Beth. How are you?
I'm doing good. How are you, Brandon?
Doing well, doing well. So it's getting a little chilly.
It is. I'm not looking forward to the cold.
We got through Thanksgiving.
Yes.
And here we are on the other side. And so, true to our Thanksgiving podcast, when I said, after you finish eating all your turkey, we're going to get together and talk about some automation stuff again. So that's what we're doing today. So before we jump into that, let's head into some of the things that we've been hearing going on.
Well, I want to talk about the hanwa. Hanwa's in the house.
Hanwa.
Oh, hanwa. Excuse me. It's my southern accent.
Hanwa. So yeah, what about it?
The HCR3 is.
Yeah. Oh yeah,
the demo's here.
Yeah, that's right.
So Sean can take that out. It looks like a little baby robot.
A little baby. It's actually, we are getting a lot of interest from schools and universities, a lot of the STEM type applications, and then the applications with higher level universities, 2 and 4 year establishments, because of the size and the simplicity of it. They really are interested in that. The cost being what it is really advantageous to the academia. As far as using that in a actual application, as far as an industrial setting, it could be done. It's limited reach. It's 3 kilograms, so it's pretty limited payload. So we don't often use those in those capacities, but for demonstration and for education, it's really good. So Sean's our sales engineer for this area, and he's excited about getting out and doing that. So certainly, if you would like to see a demo of that, reach out to us. Contact Sean. You can reach him through our main line 865-409-1555, and have him set up a time to come bring that robot by and let you see how it works.
Yeah, see it in person.
Yeah. See
how even though it's small, it's sturdy.
It is. It moves pretty well.
Yeah.
And so, we have that. We have our 5 kilogram demonstration unit as well. A lot of times we use that to prove out concepts. But it's mobile as well, mobile. We can take that to customer plants to use and to see and things of that nature. And in 2022, we're going to be doing even more of that kind of stuff. Mm-hmm. I believe we're going to be doing some open houses, and of course our training center is kicking back up in 2022. So robots are going to be a big part of that, and the Hanwa robots as well.
So, I also wanted to give an update on the FDA, the FSMA.
Oh, yeah. FSMA. I forgot about that. So, yeah, we talked about that 2 podcasts ago, I guess, when I mentioned.
It was the last one when I
it was.
I totally forgot to brush up on the rule.
FSMA.
And it stands for, let me find my notes here.
I was going to say, what's it stand for? I can't remember.
I know. Bear with me.
Hold on. Let's see. FSMA.
The food, oh my word, Food Safety Modernization Act.
Okay.
That's what it is.
FSMA. Yeah, there you go. So we talked about that, and I made reference to that when we were looking back in our last podcast, which was It doesn't have to be thankless.
Thankless, yes.
Yeah, and so I was talking about the great research that you did for that episode, but now that's a thing now, right?
It's the comment period was open until January 21st, and then the rule, if the rule is passed and finalized, when it is, it's 2 years for companies to comply to the record keeping requirements.
Yeah,
so it's still a little bit off, but people need to be prepared.
Well, I mean, that 2 years of compliance, yeah, that's when you've got to be able to comply, but it's going to be a process.
Yeah, and this was interesting. I found on June 1st, the FDA launched the FDA New Era of Smart Food Safety Low or No Cost Tech-Enabled Traceability Challenge. That's a mouthful. Mm-hmm. And it asks stakeholders to develop traceability tools that are scalable and cost effective. So they are working on things that are cost effective, and I guess you submit your ideas to them and they'll set it up for a challenge, I guess.
Huh, that's interesting. Yeah. So when you say June, you said January, you're talking about 2021.
That is correct,
okay,
yes.
Yeah.
So it's still in the process.
Okay.
So after 2 years after it's finalized.
Well, okay, so the comment period you said was January
21st.
It
ended.
Of 2021.
That's correct.
So the comment period's passed, almost a year passed. Mm-hmm. And so then we have 2 more years after that.
It hasn't passed yet. And it hasn't been passed and finalized. From what I can find.
Oh, the comment period has passed, but they still have to pass and finalize whatever they got.
Correct, yes.
Okay, and they haven't done that yet.
As far as I can tell, and I have looked.
Yeah, okay. All right, so that's FSMA. So that has to do with the FDA food traceability requirements that are in the makings. And again, we made reference to that in the last podcast, but that was one that we looked at in season 2, the first episode of season 2, which is industrial automation. It doesn't have to be untraceable. Mm-hmm. And that's where we're talking about the FDA.
Yes, and how the IOTA,
the
MES appliance can help.
Well, that's what I was going to say as far as their tech challenge and stuff like that. They don't need to have a challenge. We've already done that.
Absolutely.
Yeah. We can trace all that stuff, make that very easy to do with our IOTA. So.
And it's cost effective.
Exactly. Not a lot of engineering to go into that. You just have to be able to point and click.
I know. I can do it.
Well, that's... Oh, sorry. There you go. Little rain clapping. All right. So yeah. That's some good highlights. So thank you for that. So go ahead and get us started with today's title.
All right. So today's title is Industrial Automation. It doesn't have to be your biggest problem.
Oh yeah, it's for those with video. Y'all been seeing it the whole time.
I know
it's behind us. It's on our backdrop.
I should do something different, and then I'll pop it up next time.
The Vanna. Yeah. So. I keep forgetting to look behind us at the backdrop. I'm still not quite used to the video. So, by the way, thanks to all those who have subscribed to our YouTube channel and engaged with the videos we've been doing on LinkedIn and Facebook and YouTube. We want to just let you know that we appreciate that and keep subscribing, keep sharing. We would ask you to please share if you like what you're hearing, and then follow us as well, and so you can be updated for the latest and greatest stuff. So back to the title. So it doesn't have to be your biggest problem, and so that's what I alluded to in the intro. And so what are we talking about there? Well, basically, we're talking about sometimes we are getting. A lot of folks are coming to us and asking, saying, I want to automate this process for various reasons. And so we have to enter into a conversation where we're trying to discuss, is this the best? This is a good opportunity, but is it the best opportunity? Does it make the most sense for automation?
Yes, and we're going to talk about what automation is in general.
Yeah, so that's one
first.
thing. Yeah. So how can you automate? What types of automation are there?
Yes, so I want to get Brandspective.
Brandspectives. Okay.
So do you agree or disagree if on these 4 types of automation? So when I looked up the types of automation, it all comes up to either 3 or 4. Mm-hmm. And the first one is fixed automation, or what they also call hard automation. What are your thoughts on that? Is that
Do I agree or disagree with it?
Well, yeah, because we got fixed automation, programmable automation,
Okay.
flexible automation, which is also soft automation, and then integrated automation.
Okay.
Some of these seem like they blend together to me.
Well, and some of them are old terms with new words.
Okay, that's what I wanted to find out. Yeah.
So for me, hard automation is a machine or a process that's built to build one part.
Okay.
It's not really flexible. It's not a quick change. It's not got quick change tooling or changeover or something like that. It's built to do one thing.
And usually, is it large batches and stuff?
Well, that's why they do that.
Okay.
Is it needs to manufacture one part. Usually, you want it to do it. Certainly, you want to do it consistently well, not just consistent, but consistently good at high throughput. So large batches with large yield, and that's just what it does. So I'll use the same analogy that I've used for our IOTA in the past. If you've built it to do one thing, manufacture one part, that's all it's ever going to do. Without doing some pretty costly retooling and things of that nature. The other thing about hard automation is it may not be electrically controlled at all.
Oh.
It could be some of the older type industry, what's that, Industry 2 or 2.0, I guess?
With steam?
Not just with steam, but just a mechanical automation.
Okay.
And so cam driven and using things of that nature where whole lines used to be just have a common shaft, and it was being turned. It may be connected to a water wheel or a steam engine or something, but this whole shaft is just turning. And then different processes down the line would have belts that would come off that shaft, based upon the pulley side would decide how fast the opposite end of that shaft was turning for that process, and so they could tune that process to get the timing right, so that this continuous process could be just shaft driven all the way down. And then those things could turn cams. Cams are like a lobe on a shaft. So as it spins, things go out and then they go back in, and it's just like a cam in an engine that adjusts as the engine turns, the crank turns, there's a cam that turns, and that cam is controlling the valves opening and closing, and the crank is turning the pistons. And so the pistons have to be in a certain position before certain valves have to be in a position relative to that piston and things of that nature to do your cycle of a combustion engine. That's all mechanical. Now today we have more electrical control in an engine. But if you go to old school engines, we're talking about, engines probably 1960 and before. Certainly, you get back in the 1900s, the old Model Ts and things of that nature. They once that engine started, it's a complete mechanical process. Now it's electrical as far as spark plugs, but that's even being driven based upon mechanical things that are turning and spinning and creating that spark.
Okay.
And so that to me is hard automation as far as older type means of automation. But even with electric, you can be doing high-speed motion, you can be doing all kinds of things, but if that machine is built to run really one specific part and do that very well, very quickly, then that's what I would refer to as hard automation by today's terms.
Okay. And then programmable automation is obviously using programs.
Well, and even program automation, you can. So the hard automation, to me, the way I see that is more mechanical.
Okay.
Mechanically driven, mechanically timed, just mechanical. When you get into programmable automation, now we have something that we can change a program on.
Oh.
On a mechanical, you can change the program. You just have to machine a new cam.
Okay.
And so if you want something to go faster or whatever or move further, you just machine a new cam, go in there and mechanically take out the old cam, put a new cam in, and now it'll follow that motion. So that really is programming, right?
Uh-huh.
Because we're changing the way the machine runs, the timings and things of that nature. So programmable automation, the way I compartmentalize that is it's it's something we can program certain things, but we can't add anything to the system or necessarily subtract anything from the system. So mechanical items, well, mechanical meaning things you can hold in your hand. That includes sensors and things of that nature. So if the machine is the way it is, I can go in and change certain things. Like I could change a timing sequence. I might be able to even change a speed. But I can't add features like monitoring, I'm going to change the speed based upon monitoring, flow or monitoring temperature or something like that. I can't do that because I would have to add something to monitor the flow or monitor the temperature.
Okay.
And so when you're talking about specifically programmable automation, that's, I don't know how useful that is, but maybe it is. Imagine being able to go in and, your toaster. We used toaster before. I was going to say the toaster is only going to ever toast. That's what it does. Toast. It's not going to wash your dishes.
No.
It's not going to check your email. Who knows nowadays? Internet of Things. We're making refrigerators email you and all this kind. Maybe toasters will too. I don't know.
Text you when your toast is done.
Yeah. But you've got a dial on or some kind of way of saying I like my toast more toasty or less toasty, and so that is changing. Either maybe it's a time. I don't know how it works. Maybe it's a time. Probably it's a thermostat setting that says at a certain thermostat setting we're going to pop this thing through. Well, however the magic is that comes to pop your toast up, but just make it stop baking. But that's where you have to have that capability. So that is programmable. You can go in and program your toast to be different from when I do mine. I can change it, right? Mm-hmm. So that would be an analogy of programmable, meaning you can't do anything else. You can't change the force by which the toast comes out. You can't change the size of the toast that's going in to where you can do a whole loaf of bread instead of just a slice. You can't change those things, the mechanical aspects of it, but you can change how long it stays in. And so you have the ability to program that. And so programmable automation means that's all you can do is program what you have access to.
Got it.
The next one you mentioned was
soft automation.
Soft automation or
flexible automation.
And now all of a sudden, that's when we can start pulling in, again, these are my interpretations of those. This is when we can start pulling in both the controls and the programmability with the ability to change things.
Okay.
So we may do quick setups. So maybe we have linear actuators that change the size, the size and shape of the parts. Maybe you have mechanical stuff, but it's quick change. So you can do quick change tooling, quick change fixtures, things of that nature. And then you can adjust programs so that when you're running this fixture or this set of parts, or you're adjusted to accept this part, the program runs totally differently than when you've got this other part in there. Instead of all 10 steps, it's only going to run 3 steps, or and they're going to change their cycle times and things of that nature. We could do those kind of things. You can also begin monitoring stuff like, I don't know, if you need to monitor a tank level. For this part, you may need the tank to fill up or flow so many gallons of water or whatever. But for the other part, we need half that or more than that. So you can monitor the flow, you can monitor the levels, and the programming can come into play. But if this part needs 10 gallons of water in the tank, and you only have a 5-gallon tank,
it's not going to work.
It's not going to work. So you may have to change out the tank. But if you change out the tank and that's a quick and easy thing to do, then now it's flexible.
Okay.
So quick change tooling and that kind of stuff come into play.
Okay. What about the integrated?
Integrated means we're just going to take a lot of little stuff and make it all work and do one kind of centralized control system over top of that. Now, traditionally we've used SCADA systems, I guess, for that. Or you could do a centralized PLC system. We do centralized control. There's an age-old question of centralized control from a PLC standpoint, one PLC controlling many, many processes, or having a lot of small PLCs controlling their specific processes, okay, and having them report back to a supervisory controller.
Okay. And I bet there's some give and take with both of those.
Well, there is. You've got a communication, and then also, what if you start if everything's a PLC, or even better, let's say everything is the exact same brand of PLC. Is that reasonable? No.
It seems like it'd be expensive.
I mean, plants, most plants, most manufacturing plants in various sizes are trying to have standards and things of that nature. But sometimes, especially for the small to medium sized manufacturers, if you've got a piece of equipment and it has an older controller on it or some other brand of controller, but the machine works fine, there's no reason to budget in retrofitting all that and getting, ripping it all out and trying to put new stuff in just to match your standard. Or maybe they don't have the standards as close as possible. They're just really about trying to make production. And so when you start having all these dissimilar systems and legacy systems and trying to pull that together, now if you're using the IOTA,
that's no problem.
No problem. I mean, it's according to what you're doing is. We control traceability, or we control process workflow. But if you're, we're not going to control a machine. We're not going to do logic. We don't do ladder logic per se. But if you need that for your setups to get something from the ERP system or even a cloud-based system, if you're going there or whatever, I mean, we can deliver that stuff very easily. All you have to do, point and click. And so we take the place. Of some SCADA systems. So what's SCADA stand for? Acronym, SCADA.
Supervisory.
SCADA. Yeah, you messed me up. Let's do it.
Okay,
You're not playing right.
Okay. I didn't know you were doing the sound.
SCADA.
Oh, supervisory control and data acquisition.
That's right.
Woohoo.
So supervisory control, that's a centralized control system. And data acquisition. So that's what the IOTA is going to do. It's not really going to give control as far as being able to push buttons on the front of the thing and change, actually be like a human machine interface. Those machine interfaces are down there is the way we would say, or they're somewhere else. We're not a replacement for a SCADA system, I guess is what I'm getting at with the IOTA.
It goes under it?
Well, sometimes it goes under, sometimes it goes over.
Okay.
But our job is to move data to and from the enterprise systems and the operational systems, OT, operational manufacturing floor. And so certainly we could do that. But the point being that for integrated automation, being able to, as an example, let's say you've got, if everything's a PLC, that's great. But what if it's not? What if it's a CNC controller? What if it's some brand of robot, a Hanwha or something like that? What if it's on the certain parts of the process, it may be a PLC, it might be a PC-based system. All these different things that are taking place down the process, down the manufacturing line. Or the process may be on one side of the plant, and now we got to bring parts that are manufactured over there, sub-assemblies, and bring them over to the main finished, final assembly area and start putting them all together. So we need to make sure that all the stuff that took place here is known here. Because if there was a bad part made here, we don't want to run that bad part in final assembly.
No.
We don't want to spend the energy, the money, the material, the labor. And so that type of stuff is that's integrated automation to me.
Okay.
And that's even a larger scale. That's probably more industrial automation integration. But the most basic, probably what the internet would say, the most basic version of integrated automation is just making robots and CNCs and PLC-based systems all work together.
Okay. What are Brandon's two categories of automation?
Well, there's really two. If you boil it down, we talk about, there's probably three. I mean, machining, so what we call numerical control or CNC type stuff. So machining is kind of its own island. And more we're working with machines, especially if we're doing machine tending with robots and stuff like that. We're communicating with them. But they kind of have their own world. They use, if you're traditional, if you're a new student coming out of college, then they've told you know how to program CNCs, and if you're a veteran CNC programmer, you're shaking your head back and forth saying they don't know anything about because there's a thing called G-code, and I promise you, most G-code, and it's a programming language, G-codes, M-codes, things of that nature, and that's how we program CNC machines or numerical control machines.
Okay.
Computerized numerical control. It's an acronym. CNC. So computerized numerical control. And so it's kind of its own thing. So I'm not really including that.
Okay.
But even then, there's really two basic categories of automation. There's process, and then there's discrete.
Okay.
And so a process automation is automating a process. And really I always say that's what the chemical engineers are doing, right? So if you're in a chemical processing plant or even if you're in food and you're mixing foods and things of that nature, you're controlling more of a process there. There's discrete parts of it where we're opening and closing things and turning on motors and turning off motors, but we're doing it in a way that we have to, everything kind of cues off of everything else. When you're baking a cake or when you're putting together the recipe for a cake, if you put too much flour in, if you put too much, I don't know what goes in a cake. It might all come out of the box.
Some do. Well, you still have to put eggs and oil in there.
So if you put too much oil in or not enough oil or you miss the eggs or whatever, or the eggs aren't right or something. So in a process, now imagine a large company, a chemical company or something like that, if they're doing processing, they're going to be monitoring flow. They're going to be monitoring probably temperature, that kind of stuff. And we use things called PID loops.
Okay.
So proportional, integral, and derivative gains. That's what we're using. That's how we decide a process. That's how we engineer a process. And so, just a quick example on that. Why would you use what's the difference between a PID, let's say temperature control, versus discrete?
Okay.
So discrete's off or on, 0 or 1. Okay. There's no in between.
Okay.
And so my stove, on my cooking stove at home, when it's electric, and when I turn the eye on, I see the eye come on and it glows red.
Uh-huh.
And then after a few minutes, it clicks off and it fades away. And then just a few seconds later, it clicks back on and comes back. And then when I turn the temperature down, if it's glowing red, it clicks off, and it takes even more seconds before it clicks back on because it's waiting until the temperature comes back down, but it's still a discrete temperature control. That eye is just turning on and turning off. How long it stays on and off can be adjusted, but you can't say turn halfway on or only use 30% power or 60% power. It's 100% or it's off, so it's discrete. If it was being controlled by PID, it would be not that way. It would be, okay, we're going to turn you 100% as long as the temperature is far away. As your temperature starts approaching your set point, your goal, we're not going to wait until you get there and cut it off.
Because then it'd be too much.
Yeah, because then you're going to overshoot.
Okay.
So we're going to control that, and we're going to start easing back the power. So we're trying to get that control temperature, the target and the control, trying to get them to come together and just roll off, and boom, there you are.
Okay.
We're trying to do that in the shortest amount of time, but we don't want to overshoot and then come back down and then...
Because that's wasteful, yeah.
Well, it just takes longer, and if you overshoot baking a cake, I don't know what will happen to the cake, but it may not be as good, and it certainly might not be as consistent. And so, so that's the kind of stuff that process automation is. And then there's discrete automation. And that's what most machines are. That's where we're doing discrete functions. We've got a PLC involved. We may still be doing some temperature control and stuff like that, but that's not the crux of the entire process.
Okay.
We're usually making something or doing something to a part or something. We've got air cylinders that are firing. We've got electric cylinders that are moving. We may have some motion going on. There are various things. May even have robots, but it's very discrete. You can write that down a process. You're going to turn this on at this. You're going to run this process. When this process is done, we're going to do this. We're going to fire this valve when we see this sensor showing the gripper's open. Then we're going to take the next step. We're going to turn it off at this point. We're not squeezing to a certain pressure. We're not doing anything in between. It's off or on.
Okay.
That's discrete manufacturing, and that's what most general manufacturers are doing.
Would those types of automation, the fixed, the programmable, flexible, and would those fall under the discrete, or is it just
most of
am
those?
I trying to categorize it too much?
No. I think most of those are going to be discrete.
Okay.
Especially the fixed. Well, the old-timey fixed.
Yeah.
Because if it's all mechanical, you're pretty much getting what you're
Yeah.
getting. But the as you get into more flexible automation, again, we can be doing that kind of stuff. It really, I don't know, it comes down to most of the time when I see process automation, I'm seeing all of these PID controls or temperature controllers and flow controllers. They may be basing it on pressures, levels, whatever, and they're controlling various things, but they're controlling them somewhat. They're analog. Not digital.
Okay.
Digital is 0 or 1. Discrete, digital, same thing. Analog, I've always said the brain of the male, the human male, is discrete.
Oh, on or off.
The brain of the human female is analog, because it with us, with men, I'm going to say with me, it's either on or it's off. It either is true or it's false. It's black or white. And with my wife, who I love to death, it's not. It's kind of on or kind of off, or it's kind of yellow. It's kind of not. And for me, it's I've got the five. I've got Roy G. Biv. I've got the 5 primary colors, and I don't have cauliflower and all these other Crayola colors in my book.
It just makes the world
It's
more
just
colorful.
boom. That's where it is. And so for me, anything that looks blue is blue, and anything that looks green is green, and that's it. There's only green and blue, and Roy G. Biv: red, orange, yellow, green, blue, indigo, violet. How about that, Roy G. Biv? That's a very discrete way of thinking. The analog way, and just like with processes, discrete. Bam, turn it on, turn it off. We're just firing valves. We're moving to positions, that kind of thing. Process automation is more about moving it into where it needs to be perfect. And so, because you're engineering a process, you're doing batches, you're doing things of that nature. So if we're making a tablet, that's going to be medicine that you're going to put in your mouth or give to your children or something like that, we want to make doggone sure that when that's put together and as the chemicals that we're putting there are weighed out and as they're administered and everything before it ever gets made into a capsule or a caplet or a pill, we want to make doggone sure that those are dead on. Mm-hmm. That is process. That's where we're augering out or we're feeding out material. But at the same time, if you're talking about powder drink mix for your water, if they add a couple extra grams of crystals, get in that packet versus if they don't,
it's not life-threatening.
It's not life-threatening. But I would classify that as more. It could be more discreet. But if it's medication, we need to monitor the batching of that. If it's especially if we're making chemicals that we're using for, I don't know, cleaners or whatever, chemical processing where we're mixing chemicals, we have to monitor those flows. We have to, if we're having a chemical reaction that takes place, that comes with temperature, that comes with pressure, it comes with all these different things that have to happen. You're cooking something or boiling something or something like that. You have to make sure your temperatures are maintained, and they need to be maintained perfectly and consistently, and those kind of things. Even with food, we had a customer that what they do is they process food that's going to become like the TV dinner you're going to get out of your freezer and you're going to heat up, which is quite common for me. And so that's my cooking.
Oh, you add to it though.
I always do. Take the nutritional information and throw it out the window when I'm done with it. But that food's it can't be bad. It's gotta last. And we don't want to just pack preservatives in. And so they've come up with some clever ways of going through and doing all the things that I don't know about, to pasteurization and all this kind of stuff, to where they can get the food in such a way that it can be flash frozen. And then when you heat it up, it's just as good as the day it was cooked, and it's not packed full of preservatives and all this kind of stuff. And so to do that, their process has to be They do that under pressure. They do it under temperatures. They control temperatures, pressures, flows, all kinds of stuff to make sure that as this food packet is going through this process, that everything's where it needs to be. That is process automation.
Okay. All right. So what are the hardest manufacturing processes to automate?
Well, I think that comes down to why you're automating.
Okay.
Brandology.
Okay.
We've been talking about this for a couple of I guess since the beginning of the podcast. Brandology. 4 reasons to automate. Mm-hmm. Quality consistency, decreased cycle time, reclassification of labor, and flexibility, quick setup. There's also one in there that we haven't added. We may need to add a 5th one. I was having a conversation the other day with a customer, and the reason they wanted to automate was they were concerned about the operator's safety.
Okay.
So they felt like if they could automate this process, it would be a safer process. And I'm not sure where that would fall under.
Reclassification of labor?
Yeah, I guess it would.
It could. I mean, because you're trying to take the labor
We're
from
pulling
that.
them away from, but in that case, I mean, reclassification was going to happen anyway, but the crux was because they were concerned about the safety of the operator, because the process had changed a little bit. It wasn't quite as safe a manual process as it used to be.
Okay.
But anyway, so those 4 things, I would say it really comes down to why are you automating? It's got to be. It doesn't have to be one of those 4, but I mean it can be more than one of them, multiples. But one needs to be your primary goal. Mm-hmm. And so, which is the hardest? I think we need to add a new list.
Okay.
Brandology different list. So let's call it the top 4 ways to determine if a process is worth trying to automate.
Okay.
And really, I want to come down to this. Let me back that out a bit and make some explanation there. The majority. So what's trending?
Robots.
The majority of what's trending right now in our world is automation, but more specifically, just put a robot on it. And when they're talking robot, they're talking an articulated arm, 6-axis, 5-6-axis articulated arm robot. Just put a robot on it. And it may be industrial, it may be collaborative, but just put a robot on it. And it makes a lot of sense. If you've got a 6-axis robot, you've got some things that you can do. But
you have to be realistic, don't you?
You kind of do. And so some of the stuff, and we've talked about this before, when I talked about the wiggle jiggle.
Yeah.
There are some things that a human can do, and and I'm not talking about things that a human can do like, being a slalom skier or something like that. I'm talking about the mundane, not mundane, the little unknown, not even you things you don't even, the nuances. Thank you. That they don't even think about, that you just do. Mm-hmm. And you don't really.
You don't realize you're doing it.
You don't realize you're doing it. And the wiggle jiggle is one of those. And what the wiggle jiggle is in this case, I was watching. Customer wanted to automate a process. It was a machine tending process where it was a CNC lathe. And so the lathe would do its thing and, trim down the part, and it was a finished part, and it was ready to be taken out. And even though the chuck would open, the part was stuck in there just a little bit of stiction. And the operator reached in and kind of twisted his wrist like, if you're riding a motorcycle. Yeah. Kind of did a quick little twist and pull at the same time. Twist and pull. Wiggle, jiggle. He kind of moved it and got it out of there. And it broke free and he pulled it on out. They said, we want to automate that process. I said, how often does he have to do that little move there, the little wiggle jiggle move? Sometimes he does, sometimes he doesn't. Well, the robot's either got to do it all the time or none of the time. Mm-hmm. If the robot does it all the time, and trying to program in wiggle jiggle.
Oh, goodness gracious, I couldn't imagine.
Yeah, I mean, because there's a feel to it, right? So, the human brain's got You're feeling. You can feel what's happening. You can feel when it breaks free and things of that nature.
You can see it.
You can see it. You got all these senses, and so those kind of things. So I've come up with a new list. The top 4 things are the top 4 ways to determine if you have an application that's worth automating. If you're talking about just putting an articulated arm robot on it.
Okay.
So if you're unsure, and I think that's what we've got. So the question was, what are some of the hardest manufacturing processes to automate? It's hard to classify that. I mean, certainly, there are some that are just
on
really
the internet.
hard.
It was like what was it? Material handling and final assembly. From what?
Yeah, but sometimes material handling is a no-brainer. And
okay.
So how can you determine that? Okay, so here we go. The top 4 ways, if you're struggling with that, put mittens on it. If you have an operator that's doing their stuff, do you know what mittens are?
Yes.
They're not gloves.
I should have brought one.
They put
Your 4 fingers are in one piece and
Yeah.
your thumb's in the other.
So you only have 2 appendages.
Yes.
Okay? So if you can put a mitten on your operator and they do it, they can do it. They can still do the process with no problem. That's a good sign.
Okay. So as long as they can go like that.
Yeah, like crab claws.
Okay.
Number 2, tie one arm behind their back. Okay? We're talking about one robot, not 2. Now, granted, we have Motoman robots, and they have their DA, their dual axis that has dual arm, and it's not dual axis, dual arm, and it's really cool.
It is.
It costs more.
I bet.
You know why? Because it's 2 robots, and so yeah, you tie one hand behind your back, so you can't use 2 hands, even if you have mittens.
So if you have a mittened hand, just one mittened hand.
That's right. One mitten arm.
Oh, that's right. Okay,
Yeah.
one mittened arm
Yeah,
because you
yeah.
still have your arm.
The mittens on your hand, you still have your arm. So because it's a 6-axis articulating arm robot works similar to a human hand, and that's what most people are thinking is they're watching this person do this stuff and they're thinking this is no problem. Okay, but sometimes it is. So put a mitten on them and tie the other hand behind their back because sometimes they'll inadvertently reach up, take this part, and hand it off to the other one. And in doing that, they change. They're doing a passover of parts. That's one thing. I mean, even between 2 robots, transferring parts.
You have to program each
All
one of
of
those
it has to be
moves, don't
programmed.
you?
Yeah.
Okay.
And then put a blindfold on them.
Oh, dear.
Okay. Now, I mean, if we're getting down to the basics here, if they can put a mitten on, tie one arm behind their back, and put a blindfold on, and then one last thing,
Okay.
their feet are planted on the floor. They can't move.
That's right, because unless the robot's on something.
Well, you can do that. You can.
Oh, you're getting into other costs.
But
I'm
now
sorry.
you're getting into more cost, more complexity. So many times, especially in the last few months, with the labor shortages and things of that nature, we are blessed to have many, many opportunities to go out and talk to folks about how can we use a robot to automate this process. And the first thing, now here we're going to rant. I mean, this is my rant.
BrandRant.
The first thing they go to is ROI. And they base that upon this is our biggest issue. This is our biggest problem. And we can solve this it's like we win the lottery, right?
Uh-huh.
And of course we want to help you with that. I mean, of course. We want you to win the lottery. But when you start looking at those processes, you can automate. I've said this forever. You can automate anything if you have enough money, enough time, and enough patience. Money because
It's going to cost.
it's going to cost. Sometimes it's going to cost a lot. Time because the more complex it is, the longer it takes. And patience because the more complex it is, the more you're going to want to pull your hair out. And so, and I don't.
Is that what happened?
I don't have that luxury. Yeah, yeah. So if you want to look at something in the plant, especially now, where most people are looking for because they're focused on ROI.
Mm-hmm.
You know, I go back to an analogy of a report, and this is an IoT related analogy, but we were we had a customer, we were using, there was an IOTA user, there are an IOTA user, and they wanted at first, help us, we want to know all the downtime events, just a count of downtime events, and they would keep up with what kind of downtime classification it was, but what's the total number? So they created this, and we helped them create this report that said for this, on this line and all these processes, through your entire processes, through your plant from soup to nuts, these processes at each one of these machines, they even got down that granularly, down to where this type of event and this type of event, we keep a count. And so they had this graph that showed their top four, I think, highest downtime events.
Okay.
Just by the number of occurrences.
Gotcha.
Okay. And there was one that, number one, and then number two was slightly behind it, and then number three was way down, pretty far down as far as number of occurrences. And number four almost didn't make the map. I mean, just didn't happen often at all. And so they were doing all of their capital expenditure, all their focus. They were bringing in all these folks and machine builders, and that's why, we were there to help consult and that kind of stuff. How can they reduce on this number one column the number of downtime events? Well, as we worked with them in a consultative way, the question came up, how much downtime does all this equate to?
Yeah.
And they said, we really haven't looked at the downtime, accumulated downtime for these events. And so they started, they had the IOTA, so now that was an easy thing.
Yeah.
And so they did some pointing and clicking and created a new graph that showed total downtime for each one of those accumulated processes, our downtime events. And they laid them atop of each other. And it told a totally different story. What it said was the first category, and even the second category, but the first category completely, was all these occurrences. The total downtime was not even in the top four.
Wow.
So it was happening a lot, but it didn't take long to fix.
Okay.
You get down to number four.
That barely showed on the map.
Barely showing how many downtime events, but to fix it, you measured in hours.
Oh.
So suddenly your amount of downtime that you actually realized from your least squeakiest of the wheel is where you should be spending your money. The same thing should apply to what are we going to automate. So before you jump into doing all the steps to say, this is what we want to focus on, we want to bring in an elliTek, show us, help us, consult with us, help us to automate these things. I would suggest use these new 4 reasons to decide if an articulated arm robot or some type of automation is going to be feasible. And if it passes that test, then use that to set up your 2, 3, or 4 potentials and start your ROI analysis and feasibility studies on those.
Okay.
That'll give you the shortest term, highest return. Now, it's not going to win you the lottery, maybe. But let me tell you something. What they realized was if we spend all this money on what we were originally going to spend money on, and we realized a 10% improvement on downtime, their total downtime was like less than 15 minutes.
Oh.
So 10% would be 1.5 minutes of improved downtime. The other one was measured in hours, which I think it was getting close to 2 hours of downtime.
Wow.
So that's 120 minutes. So now 10% yields 11 minutes of improvement. It's a much better payback because that's 11 minutes added to parts going out the door, and it's the gift that keeps on giving.
Yep.
And so think the same thing. So let me review those again. Put mittens on it. Tie one arm behind the operator's back. Put a blindfold on them and tell them their feet are tied to the floor. They can't move. Now, how do we get past that?
That's right.
So if you can't put a mitten on it, we've got to get more expensive grippers Okay, maybe even grippers that are more analog than discrete, where we can do pressure-based gripping and things of that
so
nature.
they can tell how much pressure when they're picking up something.
That's right.
Okay.
That costs more.
I bet it does.
The second thing, tie one arm behind its back. Maybe we need 2 robots working together. Mm-hmm. That's more programming, more engineering, more cost, more time. Blindfold it. Well, if you need to see, we can do vision systems. We can even do 3D vision systems, but they cost.
Yeah.
And there's a complexity with it. Vision systems themselves, we can set them up in the lab environment to work perfectly. But as soon as you move into your plant and the light changes, or you upgrade lighting in the place, or you add a skylight, or open the window, pull the drapes back, whatever, vision systems, vision guided robots can need constant supervision.
Okay.
They can need maintenance or management. And then stand in one place. A lot of people are pushing for what we call the 7th axis. 6-axis articulated arm robot, we stick it on a thing that moves. Or an AGV.
Okay.
Now, the AGV is still new.
Those are neat.
They're neat. They are pretty cool in the way that they work, but they're not 100% accurate.
Okay.
So if you move a robot up into a position in front of a machine, realize that it's not going to stop in the same place.
Every time?
Every single time. So it's not going to be the same thing as having a robot that could be nailed to the ground and always reach into the same spot. If it moves up, we're going to have to do things to try to figure out where we are and adjust our user frames and things of that nature. We can do that, but there's more cost. Mm-hmm. So that's the thing that I would get to is so many people will come to us and say, we just walked through the plant, we looked at this, we noticed we didn't think that was a very hard one to do, and so that's the one we want to automate. And we start kind of, we'll have to overcome this, and you can just see them kind of sinking down in their seat, because they're like, oh, that's yeah. Or they'll come on out and tell us, this is our budget, we feel like we can do this, very, very well and get a 6-month payback or something like that. I want you to have the 6-month payback, but if you overlook some of these little nuances, it can bite you, and it can knock your budgets way out.
Yeah. So what is that, like the Rube Goldberg?
You don't want a Rube Goldberg machine. I've seen some of that. A Rube Goldberg machine, for those of you who don't know, Google it and get on YouTube and watch some of the videos. There's some fantastic things.
There are.
Yeah. Rube Goldberg is all about timing, and everything's got to be consistent, and you're relying on all these other things to happen just to make a certain outcome. But there's a lot of opportunities for failure.
Yeah, because it's a lot of chance in there.
There's a lot of chance. Everything's going to be aligned perfectly and things of that nature. And I have seen those types of moves from equipment. We've never done it. We try not to. But just seen some. If it works, we call it clever. If it doesn't work, we call it dumb, right? Yeah. So you're going to go one way or the other. But, you don't want the Rube Goldberg machine. So what are some examples of processes that can be automated? Well, we've actually been talking with some folks about polishing, deburring, and things of that nature. The interesting thing there, I would say, is think about, do you want to bring the part to the process or the process to the part? Okay. And not everybody thinks about that.
No.
Sometimes it's easier to take the part or the process to the part than the part to the process. Okay. But when an operator is doing it, a lot of times they're taking the part to the process every single time. It's according to your situation, what you're dealing with. But sometimes it's easier to bring the process to the part. So instead of taking a part with a robot and moving it up against a polishing wheel, it may be easier to attach the polishing wheel or the whatever you got, the grinder, the deburring unit, whatever, to the robot, and let it come to the part and do stuff to the part while the part's fixed.
Okay.
Let's see, material handling. You mentioned material handling. The internet said was tough.
Yeah. You think it's an easier one?
Well,
it depends, I guess. It's
material handling's probably what most robots are doing.
Okay.
Saying material handling is so generic, though, That's like saying math is hard.
That's true. 'Cause
Well, I mean, if you're talking about simple addition compared to complex,
algebra and geometry.
calculus
Oh,
or
goodness.
trigonometry or something like that, you're doing fourth or fifth or 100th degree integrals and things of that nature, no, you can't categorize math as hard. Some math is hard. Some material handling can be hard.
Gotcha.
Apply these. If you're not sure, apply these 4 things, and then you want to worry about hard. If your answer is, well, we can't do it with mittens, we can't do it blind, no. And then, if you can do some of those things, maybe. But you're getting harder from that point forward. If you just like, even we had, 3D systems with 7th axes and 2 or 3 robots and the best, most expensive ambidextrous type grippers.
Okay.
Human hand grippers. This still would be hard. Then let's not automate that one. Let's use a person. Sometimes you just need the touch of the human touch, and so that kind of thing. But so material handling, and then of course we always do dispensing and inspection. So dispensing, be gluing, caulking, something like that, where we're moving in a pattern. That's real good with robots. Even Cartesian robots we do that a lot with. Scara robots, and not even dispensing. We can do cutting. The ultrasonic cutters and things of that nature for cloth material, ultrasonic welding. We do that a lot with Scara type robots and Cartesian robots. But then inspection means you just got a camera on the end of the robot, or you're moving the part in front of a fixed camera. Again, do you take the part to the process, or the process to the part? Those things can or cannot be interesting. A lot of those things you can prove out too. That's why we keep robots here.
Yeah.
At elliTek.
Can we show a video?
Absolutely. You want to see a video?
Yeah.
So here's one that we've got set up. This is actually a proof of concept for a customer. Actually, it's more than a proof of concept. They're actually doing it. So this is one of our Hanwha robots, collaborative robots. Now, why do we have it guarded? I'll tell you why we have it guarded. Because it's moving faster. And you look at the end of arm tooling. Bring up that gripper. Can you bring us onto that gripper? So
one more.
Kind of see it there. So we're grabbing from the inside. So we're catching the part from the inside diameter of the part, with those grippers. So that's why they're spread apart right now. We don't have parts in this video because, number one, they're confidential, but also we don't have any just because. But that's what the tooling's supposed to do. But you can see that tooling has sharp points on the edges. The gripper has sharp points on the edges. So
we got to guard it.
For those of you who are collaborative folks that think, yeah, just tell everybody to get out of the way, we don't need any guarding. Imagine how slow we would have to be going to keep that in the collaborative realm as far as the pounds per square inch with those points. Now, if we had designed some kind of shroud around it and everything that would also house the part, those kind of things, we could possibly do it. But in this case, doing all that design and everything, we looked at the feasibility of doing that, and then the cost of just a couple of pieces of extra extrusion and some finger safe guarding. It was a no-brainer.
Yeah.
And so that's the KISS, keep it simple, stupid.
That's right.
And so that's what we're doing. Go ahead and play that again. So it's moving pretty thoroughly. And what this is emulating is picking apart, machine tending. We'll be going over. The customer will be going over and doing a quality check, and then based upon that quality check, it'll either pass or fail, and it'll either be let down the good chute or placed into the reject chute. And so there it is right there.
Pretty cool
stuff.
Yeah.
So there you go. That's a good example of that's material handling.
Well, that wasn't that as difficult as I forgot to do that.
Yeah. Seeing through those of you on video just saw infinity.
They did. Sorry about that.
So yeah, I wouldn't say that those things are too hard to do necessarily.
Okay. So what advice would you have to share with people?
Well, again, I think these 4 reasons, and I put some thought into this as we've gone through the mittens, the blindfold, the stand in one place, the one arm behind your back kind of thing. That's I'm sorry if it's rudimentary. I apologize for that, but I think that it's a
a good easy way to remember
it
too.
Is. It is, and it just brings everything into perspective pretty quickly.
Yeah.
And kind of helps boil that down. So if that saves you some time on that's the great thing. And then you get on to your other reasons to automate and your other ROI calculations as far as this is looking at the high volume task, the impacts, on the systems, the compliances, the audits, audit requirements, those kind of things come into play. And in general ROIs, I mean, the rest of that's feasibility study. But what I've seen more often than not in the last few months is folks are trying their best to find a way to get to an ROI, and they're pulling potential automation projects based upon ROI and thinking if we can do this, then we'll get the highest ROI. But it becomes so complex and whatnot, it blows their budgets out of the water, what they're really budgeting for. And so if you can pass this through this initial filter first, and then from what falls out of that, now start doing your ROIs, the benefits will be in less time, be shorter. They'll be, the ROIs, you may not, again, you're not going to... You may not do away with, we don't even need the half of the plant. We can lease it out, whatever. It's not going to be that.
Yeah.
It's not going to be lotto, but it's going to be something, and it might be lotto-like. But because now all of a sudden with the same budgets, you may be able to say, with what we would have spent to automate this one process, we can now automate 3 or 4 processes, and when you add those up, it equals what this one is, except with a lot less
complexity,
a lot less money, or the money's been spread across, amortized across, and a lot less time.
Yeah.
And a lot less frustration. So less frustration equals no heightened need for patience. And so there's plenty of reasons to be frustrated in these days and times. Let's not make automating a process one of them.
That's right.
So that would be my advice.
Very good advice.
So good discussion today. Went a little long today.
Uh-oh, did we?
Yeah. So sorry for the long podcast, but we were talking about some cool stuff.
Well, last week was or the one before was so short.
We got credit. Yeah, we got credit. So guys, thanks for joining us today. Industrial automation doesn't have to be your biggest problem. There it is, Vanna. So, we want to invite you to again share videos, share our podcast. Certainly give us your feedback, leaving comments, subscribe, give us the 5-star rating, like our videos and our podcast. That helps us to continue ahead on the search. Certainly. Check us out across all those latest and greatest podcasting. If you whatever your podcast tool is, if we're not on it, let us know,
please, because I've not done my job.
Well, and I would be quite surprised if that was true, because Beth has done a fantastic job in getting us all that. And then, of course, on social media with Instagram, Twitter, LinkedIn, and Facebook, and YouTube. And so certainly continue to listen and watch us and as we go forward. So we've got some new topics all in the makings.
We've got some lined up.
Yep, yeah, we're going to be talking about some really cool things. But I hope you survived your Thanksgiving, and hopefully now you're dialing into some things to automate. So if that's the case, please, we invite you to give us a call at 865-409-1555 or check us out online at www.ellitek.com. That's ELLITEK.com. And certainly check us out on social media.
That's right.
So Beth, let's see.
Yes, Brandon.
Beth, have a wonderful day.
You too, Brandon. Thank you all for listening. Or in watching.
And watching. That's right. We'll see you.